प्लीज आप अपना माइक ऑफ कर दीजिए सुरेश सर। Hello everyone. So again, welcome to one more session of live discussion. Our today's topic is LiDAR versus radar. I welcome Mr. Ashwini Kumar Sinha and Suresh Dwivedi ji for this discussion. So my first question is, how do LiDAR and radar technologies work?
So, this is a nice question. So, the basic principle behind the LiDAR and radar technology both are the same. Both send some kind of signal and that reflected back. And based on the time between the signals sending and the reflection, it's calculate the distance. So, but only difference is the signal type. Both work on the same principle, sending of the signal and reflecting back of the signal. So, if you talk about the LiDAR technology, then LiDAR is stands for the light light detection ranging system, LiDAR, LIDAR, and radar is stand for radio detection ranging system. So both technology use the same principle of reflection. When the radio waves reflects from any surface, then the radar is able to detect the distance by calculating the time difference between between the sending and the reflection. And the LiDAR also works on the same principle of reflection. When the light get reflected from the surface, then it calculates the distance by measuring the time difference between the traveling and the reflecting back of the light. So both work on the same principle. So these are the only basic differences. The only basic difference is the working principle. In working principle is that one use the light for the distance measurement, other use the radio bulb, but both work on the same principle reflection from the object.
Okay. So how do LiDAR and radar send and receive signals?
Okay. So generally, in case of the radars, they send the signals using the radio waves. They have some radio waves modulation and all different kind of things. And for the radar thing, LiDAR, they use the light waves and they have the laser generally laser lights and one of the photodiodes. Photodiodes, or you can say the LDRs. LDRs are not that much good, but photodiodes are better for the good accuracy. So generally they have the one laser light and another is a photodiode. So laser light emits the light. The light, as you can see, know that laser lights are the polarized light. What are polarized light? That travel in one direction. Like if we see these light bulbs or the sunlights, it's diverging waves. They diverge in different they transverse, they diverge in different waves. They are not concentrated at a single point. But laser lights have the polarized wave. They are polarized to move in only one axis, one particular axis, and they are concentrated using the lens at a single pinpoint. So they don't get diverged so much, and so that they can travel the longer distance. This light also travel the longer distance, but they are not concentrated at a single point. And because of this, their intensity got diverted, and their intensity got decreased with the distance because it got diverted. But in the laser thing, they got concentrated at the single point even for the long range. So this is how the LiDAR works. They have the laser light, that is the polarized light, and one is the photo detector. So it sends the light, and the reflected light came back to the photodiode, and then it will calculate the distance. But in this kind of LiDAR or radar, there are two you find there are two variations in the market. One is the one is the simpler LiDAR that will tells you the depth and the distance at the in front of it. In front, they might have the range between the 180 degree to 90 degree or something, that those range. They only gives you data around that range. They are not movable. And if you want to know the data behind that, distance behind this, they will not be able to provide that. But there is a second type of LiDAR that available in the market, that is 360-degree radar. So what do those radars have? They have the laser light and the photodiode, and that rotate with the motor, and they have the angular calculation inside, circuit calculation circuit inside it, so that they can calculate that. As you can see here, I have one of the LiDAR here. You can see here in the camera. So what it have? It has one of the controller here that controls of the LiDAR, LiDAR, and this is the motor. So this is 360-degree LiDAR. So here you can see, as you can see here, it have one laser light here, and one photodiode. There are two holes are there in this LiDAR, and this rotate like this. This rotate in the direction like this. So this rotate using this motor, and then they have the one of the Hall effect sensor or rotary encoder, using which they will able to get the angle as what angle this is. So they can give you the angular data and distance data in 360 degrees. So they can scan out the whole environment in 360 degree and give you the data around itself, that these are the objects. And using the point cloud technology, they can make a map around yourself. They send the signal using the laser, and another photodiode reflected, that reflected laser light will be received by the photodiode, and the distance will be calculated, and using the Hall effect sensor or the rotary encoder, it will be able to get the angle, and then it will be able to tell at 0 degree the distance is 10 centimeter, 100 centimeter, or 100 centimeter, and at 1 degree and 3 degree and 4 degree, and in this way 360 degree, it gives the distance data of the 360 degree. And all these 360 degree, then all these data are then they combine together to make a point cloud thing, and it will give you the map of all around this. So there are two types of LiDAR. One is the longitudinal LiDAR that will give you the data around the 0 degree to the 180 degree or something like that, this range. So whatever the object that is in front of them, then they give you the distance of them. But there are 360-degree LiDAR like that. They have the motor here and the rotary encoder, and give you the 360-degree data. And the same thing goes with the radar as well. There are several radars that emits the radio waves in all directions and able to detect the things in all directions. And there are radars that have the that can only reflected from the front side, and it have the angle range between the 0 to 180 degree. So these are the same thing, and both the principle are also the same. And second thing is for the radar thing and the LiDAR thing. So as the LiDAR use the laser waves, and most of the laser waves, laser lights are not good for the human. Like very high intensity laser lights are not good for the eyesight, and it also burns the skin. So for the LiDAR, we have to select the range of the wavelength wisely. The LiDAR wavelength range is around 750 nanometer to 115 nanometer. This is the range of wavelength range on which we need to work out. Otherwise, it will be it will be harmful for us. And these laser lights need to be certified. Need to be get certified with the FDA and all those things, so that we can use in the real life. Otherwise, they cause problem for us. And for the radar things. These radio waves range generally between 1 centimeter to 30 centimeter in common system, wavelengths ranging between those. And for the radar and LiDAR, and the LiDAR use the laser waves. So most of the objects reflects the light. Wherever it falls, it reflects that. Wherever the object falls, it reflects that. For the transparent object like the glass, sometimes it suffers, but almost it works. But for the radar thing, there are few areas where these radar waves, these radio waves get observed. Like you might have seen that there are There are several types of, the fighter jets are there in the market, that we call stealth fighter jet, that have the certain kind of coating on their body and certain kind of shapes on their body that can't detect by the radars in the market. In the area, there are many radars in the defense system, and there are many stealth fighter jets are in the defense system that are not detected by the radars. You might have heard in many scenarios that this country have send a fighter jet and it is not detected by the radar. So these are the one of the disadvantage of the radar, that it is these are radio waves, and there are certain kind of objects paint, and there are certain kinds of shapes can be made that can absorb the radar waves, and that is not been detected by the radar. But for the LiDAR thing, this is different because it's the light and it will reflect. Even though it's a transparent, it's somewhat of light will reflect from that. So it's more better than the radar things. So these are the two differences, and this is how they both transmit the light and other things.
Okay, so what are the differences between the light used by LiDAR and the radio waves that is used by radar? And how do these differences affect how they work?
Actually, the primary difference between the LiDAR and the radar arises from the type of the wave they use. In case of the light waves for the LiDAR and the radio waves for the radar. So these differences affects their functionality, performance, and the application. There are various ways. First, consider the wave used. In case of LiDAR, that is, as its name indicates, light detection and ranging. So it uses light waves typically in the form of the laser beams, which are in the visible ultraviolet or near infrared spectrums. While we are talking about the radar, radio detection and the ranging, so it uses radio waves which have much longer wavelengths than light waves and are in the microwave area in the radio frequencies. Now, next one is the wavelength and the resolutions. In case of the LiDAR, then consider because light waves have much shorter wavelength, so LiDAR system can provide much higher resolution. So they can detect smaller objects and the finer details, which is used in applications like autonomous vehicles, topographic mapping, and the environmental mounting. While we are talking about the radar wavelengths and resolution, in case of the radar, actually radio waves have longer wavelengths, centimeters to meters. So, which leads to lower resolution compared to the LiDAR. However, radar is effective for the detecting larger objects and can work over the longer distance. Now come on the penetration and wave weather resistance. LiDAR light works don't penetrate through the obstacle like cloud, fog, or rain very well. So, LiDAR performance is reduced in poor weather conditions or when there are obstructions. It is not suitable in these weather conditions. While we are talking about the radar, because it is used a radio waves, so radio waves can penetrate cloud, fog, and rain more effectively, make radar more suitable for detecting objects and measuring distance in advanced weather conditions. Now come on the ranges and power. In case of LiDAR, because it is the light waves scattered more easily, so LiDAR typically works at shorter range, a few hundred meters, compared to the radar. It requires more power to cover larger distance effectively. Now, when we are talking about the radar, because it is radio waves travel much farther and can detect objects over longer range, up to hundreds of the kilometers in some cases. This makes radar more useful for the long-range application like air traffic control and the weather monitoring. Now, come on to another object detection. In case of the LiDAR, first consider, due to its high resolution, LiDAR is better suited for detecting a small object and providing detailed 3D representations of surroundings, which is critical for precision tasks like mapping or autonomous driving. Now come on the radar. In case of the radar, because while radar is less precise, it excels in detecting the velocity of moving objects and tracking them over the long distance, which is advantageous in applications like speed monitoring and the collision avoidance. Now come on the main difference, which is the cost and the complexity. LiDAR system tends to be more expensive due to precision, laser, and the sensor involved. They are also more sensitive to environmental conditions. Now, radar systems are generally less expensive and more robust in harsh environment. So they provide lower resolution. So in brief, we may say that the LiDAR offers high precision and detailed imaging over shorter range, but struggles in the bad weather, while radar excels in long range detection and the advanced condition, but provide the less detailed data. So that's all.
Okay, so how accurate are LiDAR and radar when measuring the distance and identifying the objects?
The LiDAR and radar are both accurate in measuring distance, but they differ in precision objects identification, capabilities, and the effectiveness, various conditions. First consider the distance measurement, accuracy in case of the LiDAR. Because the LiDAR systems are highly accurate for the distance measuring, typically with an accuracy on the order of the centimeter, they use the time of flight principle, measuring the time it takes for the laser beam to hit an object and then return to calculate precise distance. This level of accuracy makes LiDAR ideal for applications requiring high precision such as 3D mapping, autonomous vehicles, and the geospatial surveys. In case of the radar is generally less accurate than the LiDAR in measuring distances with the typical accuracies in the range of the meter. However, radar system can still provide a reliable distance measurement over much longer range. Their longer wavelength means they are as precise as LiDAR for detecting the fine details, but they excel at detecting the objects and the distance in poor weather conditions. Now, another is the object identification accuracy in case of the LiDAR, because the LiDAR's uses short wavelength light waves allows it to produce highly detailed, highly resolution 3D representation of its surrounding. It can identify small objects and features This accuracy makes LiDAR effective in environmental where precise object identification is crucial. In case of the radar identification object accuracy, radar on the other hand is less accurate for identifying the object. It can detect larger objects like vehicle or aircraft, but due to its longer wavelength, it provides lower resolution data. Radar can struggle to distinguish between the objects that are close together or identically small. Stationary objects with fine details. Now, impact of the environmental condition. When considered the LiDAR, accuracy can be affected by the environmental conditions such as fog, rain, or dust, as light waves can be scattered by these particles, leading to reduced performance and accuracy in the adverse weather. Now, when we are talking about the environmental effect of the radar, so radar is more robust in harsh environmental conditions because radio waves can penetrate fog, rain, and dust without being significantly scattered. This makes a radar more reliable in an environment where visibility is low, so it may still lack the fine detail and the precision that LiDAR offers. While we are talking about the range and accuracy, in case of LiDARs, accuracy is dismissible over longer distance, typically performance best in the range up to the few hundred meters. Beyond this, precision of the distance measurement can degrade due to scattering and signal losses. While we are talking about the accuracy of radar, because radar can maintain accuracy over much longer range up to the several kilometers, and it is especially useful for the long distance application such as air traffic control and weather monitoring, while not as precise as the LiDAR at short distance. Radar's performance is relatively stable over the extended range. So in brief, we may say that the LiDAR offers high accuracy for the short range distance measurement and detailed object identification, but affected by the poor weather. In case of radar is less accurate for the fine detailed, but it highly reliable in advanced condition in the over a longer distance. That's all.
Okay, so what are the main uses of LiDAR?
So generally, LiDARs are used in the autonomous vehicle or ADAS system, or in the robotics or indoor, like you have seen the vacuum cleaners in the room, indoor vacuum cleaners or indoor robots in the warehouses, or robots that are made by the Gray Orange and many other different companies, or the vacuum cleaner indoor robots. So generally, they use the LiDARs because LiDARs are good for these kind of usage, for the robotics, for the ADS and autonomous vehicle. Because as you can see, uh, these are the simpler, these LiDARs have very simpler, very simple, and they only have these kind of the lasers, and then the photodiode and the motor available here, and these can rotate and map the whole room by rotating itself like this, and it can map the whole. So in most of the vacuum cleaner might have seen these kind of LiDARs on the top of the vacuum cleaner that is moving like this, and it is mapping your surrounding and autonomous moving. Or might have seen the many autonomous car from the Google, Uber, Ola, or many different other company or making the autonomous car, might have seen something like this mounted on the top of the car and rotating and mapping of the things. Or Google Maps also use similar kind of LiDAR. So generally, these LiDARs are used where you need a high accuracy of distance measurement, and where the effect of weather is not that much. Like like Suresh sir have already told you that LiDAR suffers in the weather condition, extreme weather condition, like very foggy environment and very snowfall environment or dust and mud, because these scatters the light, these reflects the light. So if there are lots of snowing in front of the LiDAR, this kind of LiDAR, so it can detect that as an object, and it might not tell you the correct distance. It might tell you the random distance based on the light reflected from that snowfall. But so in this kind of scenario, these LiDAR suffers. So generally, these are used in the autonomous or ADAS system, where these are not these or indoor robots like or indoors robots like vacuum cleaner or warehouse robots. And radars are generally used in the defense system, and also very little bit in the autonomous vehicle, because lidars can detect accurately for the object detection thing, or you can say the pedestrian detectors thing, and they are little bit faster than the radars. So radars are generally used in the defense and somewhat also in the autonomous vehicle for the indoor robotic system, like indoor robots, and these kind of lidars are used. So because in indoor the weather condition is not that much change, and you need a simpler and very less in cost, very affordable system for the mapping, and these kind of lidars are best for that. And radars are generally used for in a defense system or autonomous vehicle, or where you need to calculate the distance of the moving object. Like there is a special kind of radar that is called Doppler effect radar. You can might search that. So they can might have seen lots of police officers out there have the vehicle. They have parked the vehicle or some kind of system at the side of road, and when any car cross the speed limit, then they will detect that this is your speed of your car and you have violated the speed limit of your car, and they will charge you fine on that. So how they do that? They use the same Doppler effect. So what the Doppler, how the Doppler effect radar will use? So they emit these kind of the Doppler effect radars have emit the radio waves, and when any vehicle came closer to it, move like this, then it compresses it creates a compression in the radio waves. So this creates a Doppler effect, and using that compression thing, it can be able to detect the change in the speed and velocity, and it will accurately tells the velocity of incoming car, and they can able to accurately detect the speed. So for the speed detection thing and for the defense thing, like detecting the missiles and detecting the fighter jets, radars are good, because radio waves can travel more in more farther than the radar, because it's as I've already told you, the light have a power that it can diverse. It can diverse with the distance. Even though it's laser, it will you will see the light waves diversified for the longer distance. So these are the two scenarios where we use the lidar. Lidar is generally used in indoor robotics and the vacuum cleaners and ADS system, or in autonomous vehicle. Radars are generally used in defense thing or in some kind of autonomous vehicle, and also for the speed detection using the Doppler effect. That is called the Doppler effect radar that you find in the market.
Okay, so what are the energy needs for LiDAR as compared to radar?
Hello?
Should I repeat?
Yeah. What's it?
What are the energy needs for LiDAR as compared to radar?
Yeah, LiDAR did not need that much of energy, because it's a simple laser light, and they can take the energy as much as the laser and a simpler function inside that circuit need. But for the radar thing, they need a lots of energy. They need to modulate the radio waves, and they have to emit the powerful radio waves so that it can reach further. So in terms of the energy needed from the radar and radar, the radar used much higher energy than the LiDAR, and the waves is also depend on the waves. So there are various radars called the wave radars. That is called millimeter wave radar. So these are the special radars. These can not only detects the these radars, these millimeter waves radars not only detects the the distance, not only detects the distance and object, it can also detect a lot of things and give you a lot of data. Like there are radars called the 4D imaging radars. So what it will do, it will tell you the distance, speed, angle, and also the multiple layer of information, the whole 4D image of that thing, because it passes through the objects, and it creates a whole 4D image of that object using these radars. And there are few mmWave radars that are now used in for patient monitoring. Like these mmWave radars can actually detect your vitals, like the heartbeat, your pulse rate, all those things that can be detected by the mmWave radars, because they can pass through your shirt, and they can reflect it by they can sense the the difference, micro difference in the millimeter waves reflected from your heart, and it can detect the pulse rate because without any. So there are contactless pulse rate sensors out there that is based on the millimeter wave radars. So there are Doppler radars, there are millimeter wave radar, and there are radars for the defense things. So there are various kinds of different kind of radars out there, and they use various kinds of different energy. Like millimeter use the certain amount of energy, and there works around the 30 gigahertz to 20 gigahertz, some frequency range, and then the defense they have a certain range. So for the radar, they based on the scenarios, they consume various their energy consumption varies, but generally the radar use larger energy than the LiDAR. And these millimeter wave radars can also detect tells you the data about your movement, like whether you are walking, whether you are sitting, whether you are sleeping. So there are various radars out there, that patient monitoring radar. They are all done by the radar. So what they do, they suppose that your patient need a privacy. They not need a camera that monitors them 24 into 7 hours. So you can't keep the camera everywhere for the patient. That wherever they go, you can't keep the camera to monitor the patient condition. And so in such case of scenario, by maintaining the privacy, they can monitor. Radar helps in monitoring them by monitoring their activity. So these are the mmWave radar. They can gives you the vitals of the patient, that its the heartbeat is this, its pulse rate is this, and whether the patient is moving, sleeping, and how much it's sleeping, whether the person is walking or doing jogging. It can, without need of any camera, these mmWave radars can detect all these activity. This can detect the person and all those things. So might have also noticed that there are automatic gates in the in the airports or in the malls. These all use the radar technology, because these are the mmWave radars. So based on the various scenario and use cases, radar might use lesser and higher energy, but in comparison with the LiDAR, the radars use higher energy, because these kind of LiDARs only have these lasers. So whatever the amount of energy this laser required, that small amount of energy is enough. And then other components, the photodiode in this kind of LiDAR, and then the motor. So they didn't use that much of energy for the detection and all those things. It works in very low energy. But for the radars, they have to emit the radio waves, powerful radio waves, so that it can reach wider area and reach to the longer range, so that they can able to detect and also show the reliability in the detection. So radars generally consumes higher amount of energy than the LiDAR.
Okay, so what are the latest improvement in LiDAR and radar technologies?
Yeah. So latest improvement in the LiDAR and radar technology is that one is the in radar technology that I have already told you. Now the radar have the mmWave radar. There are radars coming in the market for the medical purpose as well. These are called millimeter waves radar. So they are not now working in the millimeter waves, and they can detect it with more accuracy and give you the more data, like sleep, your work, and your activity monitoring. It can detect the objects and many other things. There are few radars that comes in the 4D imaging radar. They can do also the imaging by emitting the radio waves. They can do the 4D imaging, and so they are useful in the vehicles. There are the few radars out there that can detect you the angle, speed, distance, the movement, the object detection. They can detect the vehicle, the pedestrian. They can detect from the smaller to the larger object. These are all done by the mmWave radars, because of the mmWave technology in the radar. And for the LiDAR thing, it's also improved a lot with the greater, with the high accurate photodiodes and larger photodiodes and the greater, larger and more reliable lasers that can penetrate the fogs and the weather condition as well. And with the help of the AI, they can now these radars and LiDARs both are now equipped with the AI. So using the AI, they can rectify their small mistakes. Like for the LiDARs, like these kind of LiDARs, if something is if there is a snowfall around it, and then it detects the snowfall at the object that so it might be the object is much further than that is, but at the snowfall is going in from this laser, and the light got reflected by that snow particle, and it is detected as the object by this LiDAR. So using the AI technology, it might know that there is a certain pattern, and sometimes distance changing to the 100 meters, and sometimes distance changing to the 1 centimeter. So it might be the fog that coming in front of it. So using the AI, it can detect these kind of mistakes, and it can give you more reliable data, and it will also able to detect the fogs and pedestrian and all those things. And it can also using the AI, it can also able to tell you the speed and all those things, detection of the object, and more reliable object. And for the radar thing, they also use the AI thing now. So AI and the millimeter waves are the two new technology that are included in this technology that helps them in improving their accuracy, that helps them in rectifying their small errors in the by using the AI models and finding the data patterns, and they can able to where the LiDAR suffers for the rainy, foggy environment, they can able to detect it using the AI that this might be the smoke, this might be the raining, this might be the dust, so they can give the more accurate data and rectify the mistakes done by them in identifying those and suffering in those scenarios. And for same goes for the radars, they got more reliable using the AI models.
Okay, so what do you think will be the future trend for these technologies, and which sector might use them more?
So one of the major sector that emerging right now is the fully autonomous driving. Either it's the train, or it's the metro, or it's the railway, or it's the autonomous vehicle. All those, or it's the robotics, or it's the UAV. All those things, these LiDAR and radars are going to be very useful for all these things. In the UAV, these radars, combination of the LiDAR and radars, they can make a game changing for the autonomous use and autonomous working. For the monorails and the metros, currently we need a driver that need to monitor, but using the AI LiDARs and radars, we can make a fully autonomous metro system that run without any driver, or in the train we not need any kind of driver or loco pilot. They can fully work autonomously using these. And for the ADAS, a smart vehicle, it's already there in the widely used, these LiDARs and radars to help you in driving autonomous braking system, safety detection system, crash collision detection system, the Doppler effect. And it is also now being used in the missiles as well, for detecting the different kind of objects. Like suppose that there are few missiles are now evolving with the AI models, that you can implement the LiDAR and radar in front of the missile, and that can actually captures out the object, and it can lock the object in more accurate, and it will be able to navigate in with the change of the locked object and locked target, and it can navigate better and shoot the target more accurate, accurately, like in other. So in missile, in the defense radars, and in the autonomous UAVs and drones, the vehicles, the ADS system, it's now being used everywhere. And even for the radar thing that I've already told you, now these millimeter wave radars are also being used in the health sectors. They can monitor the patients without need of any camera. And any sensor on your body. They can detect your vitals, like the pulse rate, the sweating, your walking, your jogging, everything with the use of the wave radars. So these are the technology that are evolving, and these are the area where radars are being used and LiDARs are being used widely in the future. And these are the future of the LiDARs and radars. And there are a lots of options, and this market is going to be the very vast market in next 5 to 10 years, because all of these things equipped with nowadays car, hospitals, the UAVs, missiles, rockets, the fighter jets, everything are being lashed with even the smart cameras being lashed with all these kind of radars and LiDARs. So this is a huge market that is coming for this, and you have to prepare for this market, and you have to grab this opportunity. And that's why we are doing this session. This is one of the training session, and this is the market opportunity for youth, because it is going to be one of the biggest market in the next upcoming days, because most all of these missiles, drones, this defense and medical system are going to use this technology with the AI help. They are going to become more advanced, and there is a huge market that is going to open, and it is becoming expanding to the billions and trillions of dollars of the market size. So you have to look forward and grab the opportunity in the LiDAR and radar market size.
Okay. So, how do the design of LiDAR and radar differ in complexity and ease of making them?
So yeah. So in design side, I have told you that like this is the 360-degree LiDAR. So what it do, it have the laser light and one of the photodiode, and then the controller that of the algorithm that will send the laser light data, and then the photodiode reflected data will be received, and then it calculate the distance. It's for the LiDAR, it's very simple structure. If you go for the 360-degree, it have the motor. So that it can rotate and give you data. So these are these tell you the depth and all those. And there are a few LiDARs that can emit the beams in the 4D, that can also detect the object, and it emits the laser wave in the 4D like this, and it will move like this and this as well. So it can give you the whole 4D image of this data. So for the LiDAR, it's the internal circuit and internal structure is just the photodiode and the laser. And if it's 360-degree, then it's a motor, and the 4D, then it's another motor that rotates in this direction as well, this direction and this direction. So one is rotates in this direction, then it rotates in this direction. So it's a whole 4D image that will get around the surrounding all levels, and it will also detect the object. And for the radars, they have very simpler. They have some emitting. They have some kind of radio emitter circuits out there, and that emits the radio waves like this, and that radio waves will reflect it back there. So in both of the structure, both of the thing, one is the emitter, another is on the receiver. So one emits the radio wave, another is receive the radio wave. And for the LiDAR side, one emits the laser light, and another is the photodiode to receive the reflected. So this is the basic construction behind that, and then they are very simple. They are not that much complex circuit behind this. They are very simple. One is the transmitter, another is the receiver.
Okay, so what safety issues should we consider when using LiDAR and radar in consumer products?
Yes, like I've already told you that for the LiDAR, it uses the laser waves, and laser waves are very dangerous. So if you point the laser wave for a long time at a single point, it causes the fire. And sometimes the exposure of laser waves can cause the damage in your eyes, and sometimes also the skin. They cause the skin cancer. So the laser waves or the laser light that you use in the LiDAR must certified with the FDA, and they are must in the allowed wavelength range, that is around. I've already told you earlier that is around certain millimeters. So, and for the radars, they are the radio waves. So if the radio waves are very powerful, then it might cause a little bit of problem, but it is not that much harmful as much as the laser light. So it should be within the allowed range of the FDA, that this is the allowed range of the laser light that you need to use. So you have to take care of these, the allowed wavelength range for the that is allowed by the FDA.
Okay, so anything, Suresh, you want to add to it?
Yeah. In case of when using LiDAR and radar consumer products, there are several important safety issues to be considered. First is radiation and eye safety. LiDAR system emits laser light, which, depending on the wavelength and the power level, can pose a risk to human eye. Most consumer-grade LiDAR system operates in the near-infrared spectrum, which is invisible to the human eye, making it different to detect when exposed to occurs. To address this LiDAR device are usually designed to comply with the laser safety standards, such as glass one laser, which are considered safe for the eye under normal condition. However, if LiDAR systems are improperly used or malfunction, they could potentially expose users to harmful laser levels. Regarding the safety measures, ensuring that the LiDAR system in consumer products adhere to laser safety standards in critical, manufacturer must implement safeguards such as automatic power down mechanism if the system detects potential eye exposure. In case of the radar system, especially those using the radio waves or microwaves, generally pose a lower health risk because they emit non-ionizing radiation, which does not damage tissues like ionizing radiations, for example, X-rays. However, high-power radar system could still pose a risk of the overheating tissues if the exposure is prolonged or very close range. This is more of a concern in industrial or military grade radar rather than the consumer products. So, for the safety, consumer radar system such as those in car or smart devices typically operates at very low power level, making them safe for everyday use. Still, regulating like FCC limits on the electromagnetic emission, it ensures device remain within the safe exposure threshold. So interference with the other devices. LiDAR system generally don't cause interference because they operate with the high light waves rather than the radio frequency. So both LiDAR and radar system need to be designed to minimize interference. This can include using specific less crowded frequency bands and implementing signal processing techniques to avoid crosstalk interference with the devices. While we are talking about the accuracy and reliability concern, so LiDAR system must be reliable, especially in application where the safety is paramount, such as the autonomous vehicles or the robotics. But in case of the radar system, are generally more reliable in bad weather or but low resolution LiDAR. So, for the safety measures, continuous improvement in AI and sensor fusions can enhance the reliability of LiDAR and radar, allowing system to compensate for the potential weakness and ensuring safe operation in the varying conditions. That's all.
Okay, so my last question, how do laws and regulation affect how LiDAR and radar are designed and used?
Yeah, so for the large thing for the LiDAR, it have to be past the certification range from FDA certification, and it have to be within the allowed range of FDA that I have already told you earlier, and Suresh ji have also emphasized on this. So that are the various class of LiDAR lasers. That is the class 1, and then the class 2 and the higher range. So the basic allowed range is the class 1, and for some case of scenarios each class 2 is also acceptable. So they have to comply the FDA regulations because it's related to health, and it can cause the problem to the eye and the skin and cause the skin cancer as well. So the LiDAR system must be certified under the IEC 60825-1 standard. So this is the standard, this is certification that you have to use. So while designing the LiDAR or using the LiDAR for your autonomous vehicle or any other thing, you have to must check this certification IEC 60825-1. You have this, the laser that is used in that LiDAR must have this certification. And then for the radar thing, so it's basically a radio waves. So whenever there is the radio waves, it has to be certified with the FCC, that is the Federal Communication Commission FCC certified radio waves. So those radars must certify this FCC in the American market, and somewhat in the Indian market, and somewhere also other country that allowed the FCC regulations in their country airways. But the FCC generally for the US regulations, that is the US that is the FCC, that stand for the Federal Communication and Commissions. So they have to certify with the FCC regulations, and then the EU for the European Union, and then the another certification, that is the international spectrum management, that is the that certification body is the International Telecommunication Union, ITU. It allocates the frequency that is being allowed frequency for your radar. So generally, this frequency ranges from the 77 gigahertz to the 24 gigahertz, and it may vary with the various country and vary with the regions. So these radio frequency range vary with the country and the region. I am talking about the general things. So if you go for the African, if you go for the American, if you go for the European, if you go for the Indian market, this varies. So you have to check that according to your country. For the radar, not the LiDAR. For the LiDAR, it's have to be certified with the FDA, and it have to be within the allowed class, that is the laser class 1 or laser class 2. But for the radar, you have to be certified with the IEC 60825, IEC 60825-1, and laser class 1, that is for the laser based LiDAR, and for the radar it have to certified with the FCC and then ITU. And if you are using that for the autonomous vehicle, like in the ADS system or in some kind of that is being used on the road, then it has to be certified with the National Highway Traffic Safety Administration NHTSA in USA to use that kind of LiDAR and radars in the road. So it have to be certified with NHTSA, National Highway Traffic Safety Administration. And for the European market and other different market, there is another regulation, that is UN Economic Commission for Europe, that is for the European market, as that is UNECE. Those LiDAR and radar must be certified with the UNECE if you are using it for the road. And there is another certification that you have to comply, that is the International Organization Standards, ISO 26262. This is that is for the LiDAR and radar. It have to certified if you are using those in those countries, European Union or in USA, and somewhat in other country as well. And if those LiDAR and radars are connected with some kind of cloud or internet, then you have to pass another certification called General Data Protection Regulation System, that is for the European market. So that is GDPR. This is another certification that your radar and LiDAR have to be comply if it is connected with the IoT or internet, because there need to be the data protection regulations. You have to comply with the data protection, that user data is being protected, and usually actually being notified if that data is being sent to somewhere in the cloud or somewhere else. And then it have to certified with the cyber security regulation as well. That is done by the National Institute of Standard Technology, NIST, for the LiDAR and radar as well, so that these LiDARs and radars that are being connected to the internet not being hacked, because if it get hacked, then it will give you the wrong data and might cause the accidents on the road. So you have to certify it if you are using it on the road. For the specialized road certification, I am again repeating those certification. That is the National Highway Traffic Safety Administration, NHTSA, and then UN Economic Commission of Europe, UNECE regulation, and then ISO standard, ISO 26262, and for the data privacy, the GDPR and cyber security regulation. These are the regulations that you have to follow for the specialized for the autonomous thing.
Okay, so that was all. Thank you, Ashwini ji and Suresh ji, for your time. I hope this discussion was very useful for our viewers. And if you have any question, you can post it in the comment section. We'll get back to you in the next session. Thank you.
Thank you.
Okay.